record this. And let me open the chat. The check-in code is on the screen. It's S3QU3L. No worries. All right, let me hide this thing. Okay, cool. Let's go ahead and get started. So here's the link to the slides if you want to have this access to these slides for your own reference. Again, the check-in code is on the screen. You can check into our ACM membership portal for free points. And if you're not already on our Hack Discord, there's the link to our Hack Discord. We post announcements for all these Hack events, and you can go ahead and ask questions, technical questions, and have like general conversation about Hack events. Okay, so let's go ahead and first talk about what exactly a database is. So at a very high level, all a database is a data structure that stores organized information. So for example, we can think of UCSD's database as a data structure that holds all the information about UCSD's courses, its students, its faculty, dining halls, etc. And it'll hold very specific information about each of these entities. So for example, for students, it would hold like first names, last names, PIDs, like graduation years, all that kind of stuff. So there are many different types of databases, and each of these databases store data differently. And we'll go ahead and have an overview of some types of databases in the next couple of slides. And we'll go ahead and dive deeper into what relational databases exactly are. So in all databases, data can be created, it can be read, updated, and deleted. So these four main operations are called CRUD operations. And all databases will support these, but they'll support it in a different way. And in general, data is stored with specific data types. So a student's first name would be stored as a string, like a graduation year would be stored as an integer, and stuff like that. So where can we access the slides? Let me go ahead right here. The URL is right here, hcmurl.com/SQL slides, SQL-slides. Okay, so let's go ahead and talk about a brief overview of three main types of databases. So there are many types of databases, and they all store data differently and have their own use cases. So first, let's dive into a key value database. This is the simplest type of database that exists, and it stores data entries in key value pairs. So for those of you who are familiar with hash maps or hash tables in different programming languages, this is exactly what that is. It's a hash table. So what keys are unique identifiers for a piece of data, and those will map to a particular value for a given entry. So for example, with the example we have here, a key would be something like a student's PID if we're holding student data, and the value would be all the info we want about the student. So in this example, we hold first names, last names, majors, and graduation dates. And to look up data, all we need to do is provide the database a key and it'll return a value. And most key value databases will only support simple types, data types such as strings. So in this case, we can't really use like a list to store user information or any other complex data structure. We have to store keys and values as strings here. And key value databases are mainly used in like simple caching mechanisms. And for those of you who are on the slides, I have a couple slides on advantages and disadvantages to these different types of databases, but for the sake of time, I won't be covering them in this workshop, but they are on the slides for reference. So the next type of database is a document database. So this is slightly more complex than the key value database, and it stores data in collections. So you would have like a student's collection, a courses collection, a professor's collection for a university database. And each of these collections will hold documents as entries. So a document is a particular data entry that will store info about like a particular student or particular course or particular professor. And it would store stuff like first names, last names, courses. And you can have sub-documents within documents. So you can see in this particular example, we can store a list of like all the courses of students currently enrolled in for all these types of students. So it provides more flexibility in structure than the key value database. And some examples of document databases are stuff like Firebase, MongoDB, if you all are familiar with that. Those are document databases. And last but not least, we have the relational database. So this is a database we're going to be covering in this workshop, and it defines organized data and relationships in what are called tables. So each entity will have a particular table. So for example, students would have a table. There'd be a table for students, there'd be a table for courses, a table for professors, and data is organized in this table by rows and columns. So the columns will hold fields, like the different properties of a particular entity. So for like students or for professors in this example, we would store first names, last name, like the department, the salary, the year started, stuff like that. And rows will actually hold the individual data entries. So you'd have one entry for like one professor and then another entry for another professor, another row for that professor. And you can query data using something called SQL. And we'll go over what querying means and what SQL is in the next slides. But here's an example of two different tables that we can store. Okay, so let's talk a little bit about SQL. The expansion is structured query language, and it's pronounced SQL. You can call it whatever you want. I think most people call it SQL, but you'll also hear like SQL or like school. I don't know. Do people say? I don't know if people say school, but SQL is like what most people will be familiar with. So what SQL is it's a query language used for managing data within a relational database. So in SQL, you can write queries with a very specific syntax that we'll go over later in order to create database tables with defined schemas. And all a schema is, it's a definition of columns, like what your data table will hold. So you can create database tables, you can read data that match certain constraints. Like for example, I can get all the students that have a graduation date of 2020. Or like get all the students who are majoring in computer science, that kind of stuff. You can also write data, so you can insert rows into a table, and you can delete and update data. And if anyone has any questions, feel free to drop them in the chat. Okay, so let's go ahead and get our own local database set up. So in order to set up a database, or in order to create our own tables and store data, we will need to set up a database locally. So there are many types of relational databases we can use. In this workshop, we'll be using PostgreSQL. So it's called Postgres. You'll hear Postgres, but yeah, the spelling's funky. But yeah, so this will be our database that we'll be installing and downloading onto our local machine for a couple reasons, mainly because it has a ton of SQL features that are really useful. It's very robust in its feature suite. And it's also very popular and therefore has like a lot of documentation and tutorials on it. And it's pretty straightforward to install. And the logo is pretty cool. Like it's this dope elephant right here. Okay, so let's go ahead and install Postgres locally. So you can download and install the latest version on this link. I'll go ahead and paste this in the chat over here. But yeah, we're going to walk through the installation for this. And for Windows and Mac, it should be pretty similar installation. And here are just some installation steps for during like the actual installation, which I'll go through in the right now. So let me go ahead and install Postgres. So we're gonna, if you already have Postgres on your computer, feel free, you don't need to install it again. Just make sure you have like a username and password ready. Okay, so go to Windows and then we're gonna do download the installer right here. So again, from the home page, just go to your operating system, mine's Windows, and then download installer. And we're gonna take the latest version. So that'll be 13.1. So let's download it here. All right, so it'll take a little bit to download. Let me hide this. Okay, now the download's ready. Let's go ahead and install it. Okay, cool. So we have the installer set up. Let's go next. Specify directory. So in the instructions, we say just leave the default installation values for everything. except for the password, of course, just feel free to put whatever you want. So we're going to leave this as default. We're going to be installing all these. We're going to do data, yes. Okay, so we're going to provide a password. So this password doesn't actually need to be strong. You can do whatever you want because only you can access this database because it's local to your computer. So no one else can like hop onto your database and like steal your data. So I'm just going to do password. But yeah, feel free to just make sure you remember it because you'll need it to log in. For a port number, just leave it as 5432. That's the default for Postgres. Locale, just leave it as default. And then just go ahead and hit next, and then next, and then it'll do the installation process. If anyone's having installation issues, feel free to drop it in the chat. Yeah, we'll take some time to download and install these. Yeah, it's a big download. It's like 200 megabytes or something. How's everybody doing though? Everyone's good? Tuesday afternoon. Nice, nice. You woke up 2 hours ago? That's the vibe. That's the winter quarter vibe. Nice, nice. So yeah, we'll take a couple minutes. If anyone's installation is done, feel free to like thumbs up or like let us know it's done. But we'll do like wait for like 3 or 4 more minutes. So Postgres is actually written in C, and the source code should be actually open source. So for those of you who are interested, like in reading Postgres source code and how Postgres actually works, like it's out there. But it's all like very complex C programming. There's also some Python in it. Yes, yes. This is the perfect time to plug. Yes, for those of you who want to learn how to code in Python, we're going to be doing hack.py this quarter, ACM hack. So our first workshop is this Thursday. Come through, come through. Can you share the slides link? Yeah, it's acmurl.com/SQL-slides. Okay. Yeah, and feel free in the chat if your installation's ready, just like let us know. Hack.py, is Hack.py open for everyone? Yes, it's open for everyone. Everyone, like you don't need any prior experience to join Hack.py. So we'll wait a few more minutes to finish the installation. But for those of you who have finished the installation, just go ahead and uncheck this. We won't be using Stack Builder in this workshop. So where's everyone at in the installation? Are there people still installing? Okay, cool. Yeah, we'll wait a few more. So actually, I can go ahead and continue with the workshop. Just feel free to leave the installation running. But yeah, we'll pick back up. We'll pick up when more people's installations are done. So just go ahead, if it is done, hit finish, and we'll go ahead and continue with the workshop. Okay, so let's talk a little bit more about SQL queries. So the bulk of this workshop, the rest of this workshop will be on different queries that we can run against our database. And yes, we're professional caps lockers. Okay, so a little bit about the SQL query syntax. So you'll often notice that SQL queries are typed in uppercase, and it's not because SQL programmers are angry little people. It's because there's no syntax highlighting in the SQL shell. So it makes it easier visually to see what is a query and what is like a property or value. And you'll see in the bottom, an example on the bottom. So there are a few more rules specifically for Postgres for syntax. So one of the bigger ones is that all property names are automatically lowercase. So for example, if we write this create table query, which we'll learn about in a sec, create table students, we'll actually create a table called students in lowercase. So what we need to do is we need to wrap those in double quotes. So all properties will need to be wrapped in double quotes, and all values need to be wrapped in single quotes. So what a property is like a column name or a table name, stuff like that, while values are like things you're trying to query for. So in this example below, the properties are first name, last name, users, and first name, and the values is Bo. So you can see that there are double quotes around first name, last name, the table, and the where clause, the first name. And we'll learn about this query in a couple. So for this reason, we won't actually be using uppercase for the column names because it becomes quite cumbersome to type double quotes all the time. So we'll be using snake case for column names, and we'll go into that later. Okay, so let's talk a little bit about creating our own database tables. So the first query we're going to learn is the create table query. So what this query will do, it'll create a table with the specified columns and their data types. So the syntax is here. We do create table, and then in double quotes, we're going to use table name. A general convention is to uppercase the table name and have it be plural. And I'll go ahead and reiterate that when we actually create our own tables. And then parentheses, and then column 1, space data type, comma, column 2, space data type, and whatever columns you need. So each column is required to have a data type. Databases, relational databases are strongly typed. There's no like type inference or anything. And 3 of the basic data types include integer, something called varchar, and then Boolean. Okay, so what's varchar? So varchar is basically string, but it's a string of varying length. So when we use varchar, we have to specify a size, and that size is the number of characters in that string. So by convention, for small-ish text fields like first name, last name, 255 is the convention, just because the number 255, the count, can be stored in 8 bits, which is 1 byte. So you don't need any extra storage to store the count of that, the length of that string. So that's just why we use 255. So here's an example query. We run queries in our Postgres shell, which will be open once the installation is done for everyone. But in our own shell, we would write this query, create table students, and then parentheses, first underscore name, and then the type, varchar 255, and then last name. So this would create a table with a first name and a last name column. Under categories in the download, which one do we select? So for categories, I'm not sure which specific part of that the installation is, but for the installation, just leave everything as default except like your password. And if you're downloading, download the latest version. So that's 13.1. Okay. Is everyone else's, I guess we'll wait a couple more minutes for the installation. Okay, let's continue. Okay, so yeah, let's look at an example table because we kind of abstractly talked about a table, but we don't like, here's the actual visualization of a table. So question, is there a recording of this event that I can watch later? Yes, we'll be recording this. We're recording this right now and we'll be uploading this in a few days. So feel free to watch then. Or those of you watching now, hello. All right, so here's an example table. This is the table we created in the last slide. Hold on, quick question. Okay, in the previous step, it was the drop down Postgres. I selected it. Is that correct? Yeah. You want to select Postgres. That's like, and you also want the shell, the Postgres shell. I think everything should be selected, so you just continue with that. Okay, so again, here's the table that we created with 3 entries. So the columns are first name, last name, and the rows are Brad Davis, Peter Parker, and MJ. So this is an example table, but one thing we'll notice is that what if we need to insert another student with the same exact column properties? Like what if we need to insert another Peter Parker? There's no actual way of differentiating the current one we have and any future ones we would insert. So there's no like unique identifier we have with a specific in this table. And yes, that's correct. We do need an ID column. So this is referred to as a primary key in relational databases, and it is just a way of uniquely identifying a row in a table. So every table should have a primary key column. By convention, it's called ID. And this will allow us to store rows that have the exact same fields. So we could store multiple Peter Parkers or multiple Brad Davises within our database if there are multiple students with those names. And it actually makes, another thing is it makes storing relationships possible. So what relationships are is like the bread and butter of relational databases, but it's out of the scope of this workshop. Basically, it's storing references to other tables within a table. So like you would have professors table and a courses table, and you can connect those 2 tables like professors teaching courses with primary keys. So primary keys have a special type called serial, and it'll automatically auto increment for each row. So it'll start at 1 and then go to 2 on the next insertion and then 3 on the next insertion. And we'll need to specify the primary key property with primary key, that auto incrementing. So here's a better query that we have. We create a table with the ID column, a first name, and a last name. And we're going to need to we have to specify serial primary key as the type and the constraints. So here's a improved version of our table. Now we have an ID column and we can store multiple rows and hold the same rows of information. So the primary key is an ID for a row or column. Yeah, it's for a row. So each row has its own ID. Okay, so we're gonna look at a few more queries before we start getting hands-on into Postgres. Here's another query that'll be useful. It's called alter table. And all it does is it alters the structure of a table. So what we can do is we can add columns after creating one. We can drop columns. Dropping just means removing or deleting. And we can also rename columns. So here's the syntax for those queries. We could do add column name data type, or drop column name, or rename column 1 to column 2. And then, of course, we can drop our table. This drop table query will drop an existing table and it'll delete. And what dropping means is just deleting all the data in that table as well as the table itself. So you can no longer query that table after dropping it. And there's the syntax. Okay, so now we'll get to the hands-on part of the workshop. So what we're going to be doing in this workshop is creating a database for a new fake university called UCLJ, or UC La Jolla, to be able to store data regarding students and courses. So we're going to have multiple tasks throughout this workshop to incrementally build the database and derive analytics from it. So what we're going to do now is start with creating 2 tables. So now let's go ahead and I'll go ahead and explain this first task. Basically, we're going to be creating a student table. So the university wants a way of creating a table storing the following columns. So here are all the columns we need to store: first name, last name, PID, major, and graduation year. So you guys are all going to create this table in our Postgres shell, and I'll go ahead and show how to get to that Postgres shell. And that's where we write all our queries. So here's the instructions for that. But let me go ahead and, so for those of you who have the installation ready, we're going to want to open the SQL shell. So I'll go ahead and go back to these instructions. But for Windows users, you'll find it in the Start menu. And for Mac users, you're going to go to Applications and then Postgres 13 and then SQL Shell. So I'm on Windows, so I'm going to hop into my Start menu and then scroll down to P, Postgres 13. And then you're going to want to run SQL Shell. So now the shell has opened. You can type stuff in here, but first thing we need to do is log in. So you're going to use the same credentials that you used first. So servers, localhost, enter. These are all the defaults that we set up. So just hit enter for those three. Yeah, username is Postgres. And then for the password, just use whatever you typed in. Okay, so now we're actually in our Postgres shell, and we can start writing queries. So I'll go back to the instructions. So first, you all are going to create this the students table. So remember, we're going to be using uppercase syntax and plural. So you're going to want to create your table with students like uppercase and plural. So we're going to take a couple minutes and do this task right here. You're going to use the create table query to create this table. So I'll go ahead and demo that query right here. You can go ahead and create table. And you got to specify columns. We can do like bar char 255, right? And that'll create a table. And to see a list of tables, you can do /dt enter, and you'll see those tables. So yeah, we'll take 3 or so minutes. Everyone should go ahead and create a students table for. Let me go back to the instructions. Storing student data. So everyone go ahead and create a table with these columns. Make sure it's in this exact order. A couple of notes: don't forget about a primary key, and make sure it's the first column, because we're going to need to insert data in a specific format later on. So just make sure that you have this exact ordering. And again, the /dt to show all your tables. So if anyone has any questions, feel free to drop them in the chat. Otherwise, we'll reconvene at like 4:33. Anyone else on Mac having trouble with the password? Yeah. Is anyone else on like Windows having that issue? Also. So I'll leave these instructions here. Link for the slides, I'll drop in the chat. It's acmurl.com/SQL-slides. For some reason, it says the authentication failed. Okay. So here, let me restart this shell. So make sure you type like exactly what you typed in for the in the installation. If you need to restart your installation, you can. Worst case, you can just uninstall and reinstall. But let me go ahead and restart my shell and show again. So we can go to Postgres and then SQL shell. And then for these, just hit enter, 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 enter. And then for your user, just whatever you typed in. So for me, I just typed in password. So and then enter. Yeah, no problem. Glad you figured it out. Okay, let's go back here. Okay, was everyone able to create a table for students? Okay, let me go ahead and type in this query. So we need to create a table called students with these columns. So what we're going to do is we're going to create a table using create table. We're going to call it students. And we're going to have the columns ID with the serial primary key. We're going to have first name, and this is going to be a varchar. We're going to have a last name with the varchar. So what else are we going to have? We're going to have PIDs. So we're going to have a PID. I didn't really specify the length. We can just leave it as varchar 255. But for example, in UCSD's database, it's probably a varchar 10 because everyone's PID is just 10. But we weren't given a defined length, we'll just leave it as 255. And then we have major. So we're going to want major as varchar 255. And then graduation year. And this will be an integer. Semicolon and then enter. So we've successfully created our table. We can do /gt to verify that we have a students table. Okay, let's continue on. There's one more table we need to create, and that is the course data table. So this is another table we're going to create. The university wants to be able to store data regarding courses as well. So we're going to be storing these columns as well as a primary key, of course. So we're going to store the name, the code, the professor, the quarter offered, and the year offered. So everyone take a couple minutes to write this query into their database. Let me hide this. So remember, don't forget about having a primary key as the first column. Yeah, and after these tasks, we're going to go ahead and start inserting data into our database. Okay, let me go ahead and type in this query. So again, we want to store just basic information about courses. So the name, code, the professor, the quarter offered, and the year. So let's go ahead and write that query. So we're going to create table called courses. We're going to have an ID. And we're going to have a name. We're going to have the code. And the professor. The quarter offered and the year offered. So since we weren't given any constraints on the length of the actual string, we're just going to leave it as a default 255 because it'll be long enough to store the names and the codes. Because realistically, codes are only like up to maximum like 7 characters. But we'll just leave it as 255. So we have quarter offered and then year offered as the integer. So yep, those are all the fields, semicolon, create a table. Now if we do /dt, then we see we have our courses table and our students table. All right, cool. Does everyone have this? Is everyone up to this point? Let me know in the chat if you've reached this point where you have 2 tables. So we can move on. Give me a sec. Yeah, for sure. Is it possible to check what columns our tables have? Yeah, you can. So we can run a select query, and we'll go into select queries later on to see what exactly our columns have. So I'll go ahead and demo that later. But yeah, you can use the select query. And if you have any, if you like missed a column or you need to add one later, if you want to change the data type, okay, yes, if you want to change the data type, then we can actually use the alter type query. So, or the alter table. So, okay, let's say, yeah. So let's say we have the year offered as varchar instead of integer. So what we can do is let's do alter table courses, alter column, year offered, and then set, I think it's type, let's type, alter column, and then type, and then we can do integer. So I'm going to convert it to varchar because I initially had it as integer, but let's do varchar. So alter table. And then let me go ahead and switch it back to integer. Okay, so yeah, here we're running into an error. And what exactly is this error? Okay, so it says column year offered cannot be cast automatically to type integer. Yeah, so here's a casting issue that some of you who've taken programming classes would know, like we have to specify that we're casting a varchar to an integer. So what we have to do is alter table courses, alter column year offered, type integer using year offered : integer. So they specified here. They give us, Postgres is the good guy that gave us a hint that we have to do that. So go ahead and hit enter, alter table. Okay, and I can go ahead and use the select query now. So we can do select star from courses to see what columns. So you should have these columns. So if you accidentally made PID an integer, yeah, feel free to use this query to convert PID to a varchar. Cool. And there actually should be a way to see what data type your columns are too. I'm actually not sure what that is now, so we can actually look that up together. Postgres check. Yeah, so if you want to check your column types, then go ahead and like check out like the Stack Overflow. Look at that. But yeah, again to reiterate over the types, it should be primary key, varchar, 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 integer. And then for students, it should be, let's go back here. Varchar, 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 integer. All right, so let's go ahead and move on to inserting data. Okay, so now that we created a table, let's go ahead and insert data into our table. So we can do that using the insert into query. So what this does is it'll insert new rows into our table. So The syntax is insert into table name, and then the columns. We have to specify what columns we're inserting into, and I'll explain that in a sec. And then the values, and then the values for each of those columns. So the length of this parentheses should be the same as the length of the values parentheses. So we need to specify the columns we'll be inserting data into, just because you're not always going to know what the value is of a specific column. In our scenario, you will, like we know exactly that we'll be inserting first names, last names, like the PIDs, we know all that data. But for stuff like timestamps, if you're storing like timestamps for a post, you don't always know like the current timestamp, and you might as well just let Postgres like automatically generate that timestamp. And the same thing with the ID. So unspecified columns will automatically store at null value. If the default value of that column is there, then it'll just store that default value. Otherwise, it'll be null. So if you see in this query, we have an insert into query, but we don't specify the ID. And the reason why we don't specify the ID is because Postgres has a default value for that ID, which is auto incrementing. So when we insert the first row, the ID column will automatically take an entry of 1 for that row. And then the next one will take ID 2, next one will take ID 3, etc. So here's an example query. We're going to be inserting first name, last name, PID, major, graduation year, values, and then remember single quotes because these are values, and then the following values. So here's some more examples. Again, this was the standard one is the one we just went over. We can also not insert a PID if we don't have that information. And that'll just leave the PID entry as null. There'll be no value for that particular row. And then for explicit ID, if we want to explicitly say that, then we don't actually need to specify every single column. We don't need to do insert into students and then specify the columns, because Postgres will assume that we're about to insert every single column value. So we just list all those values. But because of the primary key property, if there's already a row that inserts that has the value 3, then an error will be thrown. So that's why we just let Postgres deal with storing the auto incrementing. We don't need to be aware of that. Okay, so now we're going to go ahead and populate our database tables with some thousands of rows of fake student data and course data. So this is automatically generated data. And yes, it does sound like a lot of data, like 1,000 students, like that's kind of a lot, but it's actually pretty small. So 1,000 student rows for just for reference is roughly 200 kilobytes. So you could think of like that's like, you see 1,000 is like a big number, but it's actually so small. So it's crazy to imagine like how much data like Google and like Facebook's databases are storing, like, because they store like petabytes of data. So it's pretty rad. But yeah, we're gonna take a bunch of insert into queries on this slide. These are just haste bins that have like thousands of insert into queries. So what we're gonna do is go ahead and go to the slide if you're not already on it. I can also paste these links in the chat. But here's a link to the students one. And what you're going to do is just take all these values. You can just do Control A or Command A and copy paste it. So just copy it and then go into your shell and then paste, just Control V. And it's just going to be spammed with insert into queries. So I'll paste the other one in the chat. So these are both for students and courses. So this is just going to insert data into our database. And yeah, it's pretty gnarly to see all those rows being like flown. All right, now we're going to insert courses. So just Control A or Command A to copy, or to select all, Command C, Control C to copy, and then paste with Control V. And for the last entry, you might have to hit Enter because there's no new line character. So we'll wait a minute or so for everyone to copy that data. So again, it should be these two tables. And if anyone's running into type casting issues, let me know. Yo, what's up, Ronak? How's it going, man? I'm doing well, man. Doing well. How about you? It's a nice Tuesday evening. What's up, Kyle? All right. Has anyone not reached this point? Is anyone running into issues for this? Roderick, you gotta speed up, my boy. Quarter offer doesn't exist. Okay, so if you don't have a quarter offer column, then you can just go ahead and add one with the alter table query. So we can go back to alter table. So you can do alter table and then add column and then data type. I wrote the name of my table wrong. Can I rename it? You should be able to. I'm not currently aware of the syntax on hand. Let's go ahead and look this up. See, when you work with SQL, you're gonna have to look up a lot of stuff because this stuff is like not easy to memorize. So don't feel bad for like looking up all this stuff. So Postgres rename table. Okay, so here we have it. Alter table rename to. There you go. There's the query. Alter table, table name, rename to new table name. Why don't I have the dark theme? Because I hate my eyes. No, I'm kidding. That's a good question. Like, okay. Yeah, I probably should have it. It's just, I don't know. Windows dark theme is usually like way too dark. Like Windows does like black theme and not dark theme. So it's like not that good. But yeah, soft black. Like Discord's color is gray. Okay, if no one else is running into issues, let's go ahead and continue with the workshop. And again, if you are running into issues, feel free to drop in the chat. Okay, so now that we inserted data and we created our own table, let's go ahead and dive into reading and analyzing data. So we're using our current SQL knowledge. We set up a mechanism for storing data, and we've set up a mechanism of writing data. Like we've written thousands of rows into our database, but we aren't really doing anything with it. So how do we start reading and analyzing this data? And more importantly, how can we start asking or answering questions like the following, like how many courses are being taught in a quarter? Or like how many professors are teaching a specific course? Or like how many students are majoring in computer science? Or when is Timmy graduating? So these are all questions that we can answer with the select from query. So select from will read data from one or more tables. And this is the following syntax. It's select column names from table name, where, and then a filter. So the filter is where the magic of SQL happens. There's so many ways to filter data by conditions, and we'll go over a few of the basic conditions in the next slide. But this is where the magic of SQL happens, like the power in filtering all these data. So the next point, we can filter for specific columns, or we can select specific columns, so we can only have visible in front of us like a very specific columns, or we can view every single column. And I'll go ahead and demo this later because it's kind of hard to like visualize right now. So we can select specific columns or select all of them using star, or the wildcard star character. So this is the most important query out there because 9 times out of 10, data is almost always written or read more than it is written. Like if you think about Facebook, you're more oftentimes like looking at your feed and seeing all the posts and seeing all your friends and seeing all the online people than like creating your own post. And yeah, William says only 9 out of 10, but it's probably like 999 out of 1,000, like those applications. So there's a ton of, almost all the applications are going to read more data than it's written. Okay, let's dive into some filters. So the where clause will allow us to provide an optional filter for selecting, updating, and deleting rows. So common filters include string matches or integer matches, like so where property equals value. We're looking for exact matches. We can also do comparisons where like a property value is greater than, less than, or not equal to, etc. element existence, so we can check where a column or a property is in a specific subset, right? So we could do like select from students where major in, and then parentheses, computer science, comma, cognitive science, comma, data science, right? I can use logical operators as well to chain all these conditions. So here are some examples for string matches, exact matches, comparisons, all that stuff. So we can do select star from use students where first name is Grace. So this will select all the students, all the columns for all the students where the first name is Grace. And don't forget about single quotes. Specific columns, we can do select first name, comma, last name from students where major is computer science. So this will get all the first names and the last names of students where the major is computer science. And by get, I'll go ahead and demo in the next slide what exactly like getting means. Like what do you actually see in front of you after the select query? And again, we can chain logical operators. And then for comparisons, we can do similar stuff. All right, so let me go ahead and hop into the Postgres shell and we'll demo the select query. So let's go ahead and start with a very simple select. So let's do select star from students and then semicolon. So now you can see what's outputted is this giant table. So it has the IDs, the first names, the last names, PIDs, majors, graduation years. So there's 2,000 rows to be exact in this table. This is all data generated by a script I wrote. But so all the names are like, this is all fake student data. There's like, it's not real student data. But yeah, you can see all these students, all the IDs, they're all incrementing, all the graduation years, all these students. So you can hit Q to exit. I'm hitting enter to scroll down. You can hit Q to exit. So now let's look at courses, select star from courses. Okay, so now we have a bunch of courses. So these are all also fake courses. I wish some of them were real because these are like pretty gnarly courses. But yeah, here's the database with all our courses, and you can hit enter to see all of them. Yeah. So we're going to be filtering all this data later on. Can I get that list? Yeah, so you should actually have this list with you. On the insert data slide, populate our tables, you insert this exact list. So go ahead and hop over to these two haste bins. And this will actually insert like all these queries. Like this exact list. So you guys should have this exact list with you. Okay, so let's do a few more queries. So let's go ahead and select only a few columns. So let's do select first name, comma, last name from students. Enter. So here is a list of all the first names and the last names. Okay, can I have a question? We have a question. Can you pipe to less? The scrolling is weird. Yeah, so this isn't actually a Unix shell, or so you can't do Unix commands like ls or semicolon. This is like a specifically Postgres shell. So there's no like piping or Vim or anything in this shell. It's like just SQL. But yeah, so here's a list of all the first names and last names. So let's start having filters. So let's select, let's go ahead and select star from students where major is computer science. And don't forget single quotes. And don't forget a semicolon. Okay, so here's all the students that are majoring in computer science. So again, like the user, like as a SQL programmer, you aren't actually gonna like scroll through these tables. This is all done programmatically, and I'll go ahead and explain at the end of this workshop like how this data is actually used. But for our reference, we can go ahead and scroll through this and see all the students majoring in computer science. So we can go ahead and select from courses as well, where we do professor is. So I know Larry Gillespie is a professor. So here we can see all the courses that Larry Gillespie has ever taught. So these are all the courses, the year offered. You can see the professors and exact match. And we can also chain and like quarter, or we can do like, what are all the courses Larry taught in 2021? Right, here's the exact list. So that's a quick demo of the select from query. We'll go ahead and work more with the select from query later in this workshop. PHP lab, dude, let's go. Yes, PHP lab. UCSD, make it happen. I'm just kidding. Don't make PHP happen. Please no. All right. The as clause. So we're going to go further and further in depth into the select query because this query is so important. So the as clause selects specific columns under an alias. So all that means is it's just renaming the column. So in an example, we just have select first name as name from students. So that's all you're doing is the output name is different, the output column name. So while it does seem contrived for now, it'll become very useful when selecting rows under the aggregate functions. Okay, what's an aggregate function? Well, an aggregate function is a function on your select query that will perform computations on the selected rows. So while it sounds kind of abstract, we can see from these names, it makes a little more sense. The common aggregate functions include count, max, min, sum, average, etc. So it's like functions that are processed on all the rows that you're selecting, right? So I can count all the students who have the first name of Maokai, for example. If your first name is Maokai, you have a dope first name. Otherwise, like we can select the maximum price from bicycles, where the color is blue or the color is Vanta black. Like we can write aggregate functions in our select, like for the column names in place of the column names, and we can still specify column names in these aggregate functions. So this query would output a count, like the select count from students where first name is Maokai. That'll just output a number, and the max price as well as a number. So that's why it's an aggregate, because it performs an aggregate computation. Okay, so using all this info, let's start with another task. So now we can start answering questions like the following. So we can answer how many courses are being taught in winter 21, which professors are taught in CSC 13, how many students are not majoring in computer science. We can start answering these specific questions. All right, so this is a question for the chat, actually. Feel free to drop what you think in the chat. What query can answer the question, how many courses are being taught in winter 21? So feel free to type it in the chat, what exactly it is. Fun fact, Maokai has the highest base attack speed level 1 in the game. That's nuts. What's he doing in top lane? Put that dude in bot lane. AD carry Maokai. Okay, yeah, but does anyone have any ideas on how to write the first query? You try that in S10. Yeah, 80 carry Maokai is tough, man. Any suggestions? Select star from courses where year offered, quarter offered is winter and year offered is 2021. Yeah, perfect. Good job. So that's the query we're looking for. A simple select star. Actually, no, hold on. So everything's almost correct, but remember, we are looking at, we're asking how many, right? So we want a number. So it is almost there. What we just need to add is count, correct? So we're going to select count star from courses where quarter offers winter and year offers 2021. And let me actually type that right now. So yeah, perfect. Con, I'm going to copy and paste your command into this. Let's see if it works. Column year offered. That's year offered. But yeah, there we can see we get an output count called 4. And I can go ahead and demo that as. So what we can do is rename this column to be, instead of just count, we could do like num courses in winter 2021, right? And we'll get num courses in winter 2021. That's 4. All right, cool. How about the second query? Which professors taught CSC 13 in 2020? Again, it's a very similar concept, but we're asking the question which. Anyone have any suggestions? Okay, so I'll go ahead and just type it. It's a pretty similar concept, but all we would do is just select. So what are we looking for? Which professors taught CSE 13 in winter 2020? So we would do select star or select professor from courses where code is CSE 13 and which quarter is it again? 2020, sorry, and year offered is 2020. Right, so we see that we have Mima Noshiri and Stephen Strange who taught these courses. Yeah, that query looks good. Good job. Okay, cool. And then how many students are not majoring in computer science? Again, it's a how many question, so we would use count. So I'll go ahead and just type this in. Basically, we select count star from, let's see, how many students are not majoring? Yes, from students where major is not equal to computer science. And there's 1,650 students that are not majoring in computer science. Well, how many are majoring in computer science? 350. Okay. Cool. Does that make sense to everyone? Let's go ahead and continue on. Okay, now we know how to select data that follows a specific filter, right? Every query we've written follows a very specific filter. For example, we're specifically filtering for 2020 and CSE 13 or winter 2021. But what if we want even richer analytics that are more general? So what if we want to answer questions, more generalized questions like how many courses are taught during each quarter? Or how many courses is each professor teaching? Or give me a roster of all the currently enrolled students sorted alphabetically. Or find an average graduation year across all majors. Right, what if we want to start answering these more general questions? I'm gonna sip my water. So that brings us to the group by clause. So we're going to spend a decent amount of time on this group by clause because it's a little hard to wrap your head around first, but hopefully it'll make sense in it later. So what group by does is it groups rows with the same value of the specific property together. Okay, what does that even mean? So let's go ahead and look at this example syntax query. So we select column 1, comma, aggregate column 2 from table name group by column 1. Okay, what does this mean? So basically what we're doing, what group by does is it combines rows that have the same properties, the same values for the properties that we specify into one row. And I'll go ahead and have an example on the next slide of what that actually means. But this is very useful for aggregating stuff because we can do, for example, like select name, comma, count of major from table name group by, and then name. And like we can see all the names and all the counts. And I'll go ahead and explain that in the future. But here's group by rules. Some group by rules we have to follow. Every column has to be aggregated or grouped by. So here we have 2 columns. Column 1 is grouped by and column 2 is aggregated. And yeah, that's what that bullet says. And then we can have multiple group by columns, not just one. And I'll go ahead and demo that in a sec. And let's go ahead and look at some examples. Okay, so let's say we have an orders table with these 2 rows. So you have ID and item name, and then what we're going to do on this table is we're going to run this bottom below query. So we're going to select item name, comma, count of ID from orders group by item name. Okay, what does this do? So what's happening is we're selecting the count of the ID, right? So we're selecting all the IDs from orders and grouping them by their item name. So these are all the current, these are all the, if you see on the left side, this table is all the rows in our orders table. And you can see that item name has 2 rows that are orange, and it has 3 rows that are apple, and it has 1 row that's peach. So when we group by item name, we are combining rows that have the same property in our group by column. And how we're combining them is defined by the aggregate function we use. So what that means is I'm selecting item name, and we know that we're going to group by it, but how are we going to group by it? We're going to group by counting the IDs, right? So we're defining an account function that will count the unique rows when we group by. So group by, remember, condenses all the rows into one. So in our output table, we have orange as one row, apple as one row, and peach as one row. And what count does is it outputs the count of the aggregate of the rows. So when you use count, you sum up the number of rows that have the item name that matches, that's grouped by, right? So this will just output all the counts, the number of oranges, the number of apples, and the number of peaches. So down here, group by defines which columns will collapse the same values together, right? So in our case, will be item name. And count defines how the other columns will be aggregated when we collapse. Because when we collapse stuff, we're losing data, right? But we don't want to lose that data. When we're combining things, we want to know how are we combining them. And count defines that we are combining them by counting them together. And we can use other aggregate functions, and we'll look at those later. And intuitively, it makes sense that if we're missing any one of these, then the query will fail. If we don't define how we're combining rows, then we can't run that query, right? So hopefully that makes a little bit of sense, and hopefully it'll make more sense once we start messing in our shell a bit. All right, so let's go ahead. Where did I go? Group by. All right, so I have some queries defined here, and we're gonna go ahead and run through these queries. So let's go ahead and start very simple. So select first name from, oops, I gotta make it a habit to do uppercase. First name from students. Okay, so here's all the first names of every student. So there's gonna be duplicates, of course, because there's probably like a million Johns. Like you see already, there's 2 Johns here. John, right? And there's gonna be a ton more, right? We can even select. We can select see how many Johns are there. So let's do a count from students where first name is John. Like 24 Johns. What if I want to see the count of every student's names, right? What if I want to see how many Bobs are there, how many Sierras are there, how many Jennifers are there all at once, right? So what we're going to do is we're going to select first name, comma, count of first name from students where first name, or actually there's nowhere. We're going to do group by, oops, group by first name. And here we go. So here's a giant list of all the first names and all their counts. So we see there's 8 Edwards, 4 Cindy's, 19 Amy's, and we can go through all of these. 35 Roberts. God dang, that's a lot of Roberts. But yeah, here's a list of everything. And one thing that we want to know is, what if I want to see a list that's like increasing order? Because here's all like random count numbers. What if I want to see them in increasing and decreasing order? And we'll go ahead and go through that in the order by clause. But hopefully this is starting to make some sense. Yeah, those were basically all the queries. But yeah, hopefully it's starting to make a little more sense on like how group by works. And for count, this could be first name or it could be ID. It'll return the same value. But for stuff like min and max, you're going to want to specify like a specific column. So now, what if I want to know how many like John Does are there, or like how many Bob Rosses are there? Like how many exact first name and last name matches are there? So what we can do is have multiple group bys, remember? So what we can do is first name, comma, last name, comma, count of ID, group by first name, comma, last name, enter. Okay, so it looks like there's not that many duplicates, but we'll go ahead and really find out once we look through order by. But yeah, here's a list of all the Austin Clarks, all the like how many Dave Perkins there are, et cetera, et cetera. But yeah, since this was randomly generated, there's a very low chance that there's duplicates. Any questions? All we really know is that group by just combines rows that have the same values in the properties that we define, and order by, the aggregate function defines how we're combining the other columns. All right, let's move over to order by. So all order by does is it sorts rows based on the column specified. So let me go ahead and hide this. So we have select column 1, column 2 from table name ordered by column 1. So all we're doing is specifying a sort order for our output, right? So by default it's ascending, we can also use descending. And like I mentioned before, order by is often used with group by to sort aggregates alphabetically or by count, right? So let's go ahead and run the exact same query we ran, right? This is earlier query, and do order by count. So this is ascending, so that's not useful because there's going to be a lot of ones, but we're going to want descending. So here we go. So here's a list of all the names, all the first names, and their counts. So we see there's 42 Michaels, 47 David, 37 Davids, et cetera, et cetera. And we can see it's all in perfect sort order. Cool. So now let's answer our previous question. How many, are there any duplicate first name and last names? So here we can just do order by count. And by default, count will return a column called count. So that's why we know this will be count. But we can be explicit with that. Be count ID as count. And there doesn't seem to be any duplicates. Sad, but it's okay. Any questions about this? Okay, let's continue. Wasn't that ascending? Oh shoot, it was ascending. Wait, was it ascending? It was, wait, okay, let's do this. Let's do order by count descending. Maybe that was descending. Oh, there are duplicates. Thank you, Hassan. Thank you. Okay, perfect. There are duplicates. My bad. Okay, so actually there's very few duplicates. This is out of 2,000 rows. There's only that many duplicates. So yeah, that's pretty cool. Yes, thank you, thank you. Okay. Any other questions? Okay, let's continue. Okay, so now let's go on to our fourth task, richer analytics. Let me close this again. Okay, so richer analytics. So what queries can we use to answer the following questions? Okay, so we're going to use a similar activity as last time. So what we're going to do is we'll answer all these questions through queries. And we'll take a couple minutes for each one, just so that you guys get some practice into writing these queries. But let's first take 1 or 2 minutes to figure out how do we select all, or how do we count how many courses are taught during each quarter and how many during each unique quarter. So what unique quarter is quarter offered and year offered, as opposed to just quarter offered. So let's take 1 or 2 more minutes. Feel free to drop the quiz, what you think they are in the chat. Feel free to run them in your own SQL shell. Let's think about how we can select how many courses are taught during each quarter. Does anyone have any ideas? Select quarter offered, count ID from courses, group by quarter offered. Yeah, that looks good to me. Let's try that. Select quarter offered, count. And remember, this column, we can do anything because count just counts the actual rows. It's not going to count any differently based on what column you specify. But for things like average or maximum, then we have to specify a column, which we'll do in a couple tasks. Count ID from courses, group by quarter offered. Cool. So that's our answer. Good job, Melody. Here we have the count of all the quarters, the number of courses that are being taught in each quarter. How about each unique quarter? Because here we just have summer, spring, fall, winter. But what about summer 2020 or winter 2021? How can we adapt this query to account for that? Any ideas? All right, so what we can do is we want to find the number of courses taught during each unique quarter, right? So yes, we want to group by the year offered and select the year offered as well. Good job. So what we can do is select quarter offered and then year offered and then the count of ID from courses. So oops, courses. Group by quarter offered and then year offered. So boom. We have for every quarter and for every year, we have the number of courses that are being taught. So this is kind of like the data is all over the place here. Like there's no order in it in our rows. So let's go ahead and like add some ordering. So let's see. What if we want to see like the highest number of courses? Then we can just do group by and then order by count descending. Right? We can see that winter 2020 has the highest courses, and then spring, and then fall 2021. If we want to group, if we want to actually have like spring and summer like bunched together in like alphabetical order, then we could do group by quarter offered. Right, so we get all the falls and then all the years, all the springs, all the summers, all the winters, but then the years aren't sorted. So what we can also do is order by quarter offered and then year offered. Boom. So now this is like this query is becoming quite long, but here we have the counts of all the courses that are being offered in fall, in all the quarters, and in all the years in ascending order. So it's a pretty powerful query. This is some pretty useful data that we have. Okay, so let's go ahead and ask the next question. How many courses is each professor teaching? We'll take 1 or 2 minutes to answer that. How many courses is each professor teaching? Should be pretty similar to the last question. How many courses is each professor teaching? All right, yeah, we got some queries in the chat. These all look good. Basically, the idea is we want to select the professor and then the count from courses and then group by the professor. And if we want to derive more, if we want to order it, then we can order by count. But yes, good job, everyone. Let's go ahead and see what that looks like. Yes, Lil Pump is actually it's actually not a UCSD professor. It's a UCLJ professor. Remember, this is a fake university. So it's a UCLJ professor. UC La Jolla. All right. Count of ID from courses, and then group by professor. Oops, I forgot my caps. Professor. And then let's just order by count. All right, and let's do descending. Right, so we see Larry Gillespie has he's teaching 13 courses, and Stephen Strange is 11, and then we have the rest of the professors teaching. Where did Lil Pump get his PhD? Isn't he a Harvard dropout? Isn't that like one of his albums? I think he's got his PhD in swag. What does Lil Pump teach anyway? Select. Let's see what Lil Pump is teaching from courses where professor is. Oh, so he's teaching these courses. Keyboard Architecture Lab. That's the PHP lab. All right. Anyways, let's move on to the next task. All right. Give me a roster of all the currently enrolled students sorted alphabetically. Okay. So this is an order by. There's definitely some order that we need, and we want all the currently enrolled students. So what we need is we want to see the currently enrolled means that for the quarter we're in winter 2021. So let's define that as currently enrolled. So let's do select. I want to see all of the roster of all the students who are currently enrolled sorted alphabetically, and let's do first name and then last name alphabetically. Yeah, usually it would probably be last name alphabetically first, but let's go ahead and first simplicity, just do first name, last name. Apostrophe? I started pressing apostrophe and my shell started being weird. I fixed it. What is it? Interesting. Apostrophe. Okay, so basically you opened a quote, but you didn't close it. So Postgres allows for multi-line queries. Like I can do select star from students. And then if I don't close this, I have to do another quote and then semicolon. And then, oh yeah, I didn't open that. But all right, let's try this again. Select star from students. Yeah, but you can do multi-line. All right, cool. Yeah, so yeah, good job, Melly. First, select star from students where graduation year is greater than 2020, ordered by first name, last name. Yeah. So what we can also do is just say like, yeah, actually that's right. So we want to do greater than 2020, which is just 2021. Because you can't really tell from the graduation year, like that's when they're graduating. So what currently enrolled means is that their graduation is greater than 2020. Okay. So let's go ahead and type that. Select star from students. I say not star. Yeah, it is star. Select star from students. Oops. So again, we're doing the roster of all the currently enrolled students sorted alphabetically. So what we can just do is, yeah, students. And we do order, sorry, where graduation date, graduation year is greater than 2020, order by first name, comma, last name. Right, so this gives us all the students. If we want, we can just select first name and last name, just to make this easier to read. Right, so we get a whole bunch of, a list of all the students. Right, we got some Adams, some Alexandrias, all this stuff. But yeah, that's that. All right, last one, find the average graduation year across all majors. That's an interesting query. I don't know how useful that would be, but let's go ahead and take a whack at this. What's the average graduation year across all majors? Right, so we've only been working with count so far, but remember, average is also an aggregate function. And we can go back and see. Here is how you do average, AVG. And another thing is we want to specify the actual column because we want the average graduation year. So let's take a couple minutes to see how we can do this. So almost, Alex. Remember, we want across all majors. So I should have been more clear in this a little, but well, we'll do everyone in the system, but across all majors is I want to break down for each major, right? So I want the average graduation year broken down by each major, and we'll do for everyone in the system. Good, yeah, that's a good query. Good job. So yes, round is actually another function in Postgres. So it's intuitive. Basically, you're rounding the number in the first parameter by the decimals in the second parameter. So yes, basically what we're doing is selecting the major and then the average graduation year as grad year, or you can just leave it as whatever you want. But ideally, you have it as an alias so that you can reference it later. So you do major, average graduation year from students, group by major, and then we can order by graduation year if we wanted to. So let's go ahead and do that. So let's do, so average graduation year across all majors. So yeah, select major, average graduation year from students, grouped by major. So what does this return? Okay. So yeah, you see that the decimal places go pretty far out. So ideally we want to round it. But yeah, here we have a breakdown of the average graduation year for each major. So we see the average graduate for electrical engineering is 2023, cognitive science 2024, etc. And yeah, we can go ahead and round this as well. And you see the name is just called AVG, so it's just whatever the aggregate function is. So we can round it by 2 decimals. We can round it by, can you actually do 0? Yeah, you can. Okay. But that, yeah, so it looks like it rounds up or down. So that we don't really want this because it just says 2024 for everyone, but we can use that information somehow. Cool. All right, so that's all the analytics tasks we have. Okay, let's talk about updating and deleting data. So we're going to briefly go over updating and deleting data. It's very intuitive. Once you familiarize yourself with select, select is where all the complexity is really. Update and delete are like fairly straightforward to understand. So update will update a record in a table based on conditions. So the syntax is update table, set column 1 equal to new value, column 2 equal to new value where the condition matches, etc. So we can do we can add new values to the table, or we can update values to the table. We can increment values that are integers, and we'll go over some examples on the next slide. So here we have a few queries. We could do update students, set graduation year equal to 2024, where ID is 10. So we just, let's say one student wants to change their graduation year in our database, then we select that specific student and then change their graduation year. For courses, let's say we want to change one specific course to be another course. So we can update courses, set the code to CSE 14 and the name to be mediocre data structures, where the code is CSE 13. So this will change the code and the name fields for all rows that have the code of CSE 13. And lastly, we have update merchandise, set price equal to price plus 50, where ID is 20. So this will just increment. You can increment integers or numerical fields by doing column equals column plus some value. So actually, this is how checking into events works in ACM. In ACM's membership portal, we do incrementing, where it would be like update events or update like our attendances table and set their points equal to points plus 10 or points plus whatever the point value is in our events. So for this one, everyone would get 10 points, and that would be incremented. But yeah, in the ACM's membership portal, it uses SQL, so it's pretty handy. Okay, so let's go over a bit of the delete query. So it's very similar to the select. All it is really is the select query, but you just instead of using select, you put delete. So what delete does is it delete rows from a table based on filters. So we delete from table name where filters. So, and the filters are used the exact same way as the select query. So we have some examples. So we can delete the 10th student, just delete from students where ID is 10, so that row is gone. We can delete all the students who are comp sci grads in 2022 with delete from students for graduation years 2022 and majors computer science. And we can delete all the products in merchandise where product name is Algorithms 3rd edition. So one actual handy tip is if you're ever in like a production database or something, or you're about to delete data and you want to make sure what you're deleting is correct, what you can do is write your delete query, but then just replace delete with select star, and then you can see all the rows that you're about to delete. And then if it looks right, then you can just replace select star with delete, and it'll delete those exact rows. Okay, so that's actually it for all the queries. I wanted to go over a couple notes on SQL and like how databases actually work. But yeah, that's like all the basic queries that we went over. And you can do some pretty gnarly stuff with those queries. But yeah, let me hide this thing again, sorry. Okay, so one point I wanted to bring up is that 9 times out of 10, you don't actually write SQL. So that's not to say that everything we learned in this workshop is useless. You're definitely going to be writing SQL programmatically. But what we did in this workshop is we wrote a lot of commands in the SQL shell ourselves. But this isn't actually how data manipulation works in real applications. There's no way you're going to have like an individual person like at their shell typing in their shell and like reading data and then like writing that data somewhere, or like you can't really pipe data anyway. So what SQL is almost always done programmatically. So we need a way for programs to run SQL queries against the database. So that's done by something called an object relational mapping. So it's often called an ORM. So ORMs basically are libraries in your code, right? There's the ORMs for all different programming languages like Java, Python, like JavaScript, Node.js, TypeScript, like PHP, all that stuff. And what ORMs do are provide functions that allow you to perform database operations. So some example functions would be like ORM dot, or whatever your ORM is, dot find, and then a table name and a filter. So you can see that we're not actually writing SQL here. And this abstracts away the concept of SQL entirely, except for really complex queries where you like have to write SQL. But you can do like dot find, dot insert, dot create table, all this kind of stuff with ORMs. So if you're going to explore like backend engineering or like database engineering at all, you're definitely going to be working with ORMs. ACM's membership portal uses ORMs. And if you look, our code base is open source. So if you like look at it, there's actually not that much SQL written in it at all. It's all just ORMs, like dot find, table name, where, and then the where clause, like student equals some ID. And behind the scenes, the ORM will convert these functions into SQL, and that SQL will run against your database. So all you need to worry about is like the ORM's functions. And your program will connect to that database. Yeah. So further topics for those of you who are interested in exploring SQL programming more, we barely scratch the surface of SQL and relational databases. If there's interest, we'll definitely do another workshop covering more intermediate topics. But in the meanwhile, you can go ahead and explore some topics that we didn't cover over here. So stuff we didn't cover include relationships. So we probably should have covered relationships in a relational database workshop, but there's simply like not enough time to cover relationships because there's so much about them, like about one-to-many relationships, many-to-one relationships, many-to-many relationships, etc. And those will really leverage the primary key column that we made. We can also explore foreign keys, which are linking relationships to each other. So like courses would have a foreign key to a professor and to a student if their student is taking that course. Join clause also with relationships. Database indexing, very interesting topic on how databases optimize themselves and how you can create data structures within your database to optimize queries. Like in this 2,000 row database, or in the 2,000 row table, we didn't really run into any performance issues, but once you start working with like millions and millions of rows, queries are going to become slow, and database indexing will help us change our table in such a way that we can optimize our searching. As well as some advanced data structures like arrays, blobs, JSON, BSON, and there's like so many data structures that are in Postgres. But yeah, that's it for the workshop. Thank you everyone for coming. Shout out to the people live who are stayed with us the whole way. What about CSON? Dude, I don't know, man. Like there's probably so many SONs out there. JSON is, for those of you who don't know, JSON's JavaScript object notation. BSON is binary JSON. CSON, like there's a bunch of CSONs. But yes, thank you everyone for coming. If you want to learn more cool topics this quarter, please fill out the URL acmurl.com/hackrequest. We want to teach topics that you guys want to learn, and SQL was one of the most wanted topics to learn, so we provided. So please, if you're interested in learning more cool topics, fill out the form. And if you're interested at all in helping out during workshops such as this one, please join the Hack Squad. You can apply to join Hack Squad, which is basically an ACM Hack staff program. And you can tutor during workshops, help answer people's questions, and you can actually teach your own workshops with our mentorship. So if you're at all interested in doing any teaching or any tutoring, then please apply to join Hack Squad with the URL below. But yes, thank you everyone for coming. Woohoo. That's it. And yeah. Let's go ahead and stop the recording.
Go Shravid. Nice.
Yes.